Hello, this is video 15, and this is going to be going over systems of equations and solving those by graphing. All right, so first we need to kind of figure out what is a system of equation, okay? Well, it's multiple equations grouped together. If we have two equations, then there will be two variables. All right, so that's what a system is. The next part is a solution is a point that is in both equations. So that mostly means where those two equations, where their graph intersects, is what we're going to be looking at a lot today with our graphing. Okay. Now there's three types of solutions that we could have. All right. We could have no common solution. That means we have parallel lines. They're never going to intersect. Okay, kind of like the interstate. Those two things never intersect. Okay. Infinitely many solutions. Okay, that's where we have the same line and it just overlaps itself. So it's like you have two different lines two different equations that when you reduce them, they became the same. And it's just every single point is going to be on both lines, okay? And then the last one is one common solution, and that's where they intersect at a common point, okay? So we're just going to be going over three examples today and graphing those and seeing what happens. So for these, we are wanting to be able to graph both of these. Now this first one I can graph, okay? It's already in slope-intercept form. That's going to be really easy to graph. I need to kind of fix this second one so that it is a little bit easier for me to graph, okay? So I'm going to subtract 7 from both sides, and then I've got y equals negative 4x minus 7. Okay, now I have something that I'll be able to graph. All right, so let's go ahead and let's graph this first equation. My y-intercept is at negative 1, and I'm going to go up 2 over 1, up 2 over 1. All right, and I'm going to actually let's do a couple on this side. All right, so I've got my first line. Okay, now our second one, it intersects at negative 7. All the way down here, and my slope is negative 4, okay? So I can't really go down anymore and over to the right because I'd be off my graph, so we're going to go backwards. So we're going to go up 4 and over 1, and we're going to go over left 1. As we can see, that point right there, that big point, that is going to be actually where we intersect. Okay, so we draw our line, connecting those, and we're not actually done, okay? What we want to do is we actually want to tell where our solution is, okay? So we know we have one solution, and that is going to be at negative 1, negative 3. Okay, so always make sure you say where your solution is, okay? All right, moving on for our next example. All right, again, that first equation is good to go. We can graph this as is. The second one, we're going to have to move it around and simplify a little bit, okay? So first, let's subtract our 18x. So we've got negative 3y equals, and I'm going to put that negative 18x first, just so that it's in that mx plus b format, okay? And then let's divide by negative 3. We've got y equals 6x minus 7. Okay, now if you guys see, we've got the exact same equation. So even though they didn't start off looking the same, we now see after we've reduced it and simplified that yes, they are the same. So let's go ahead and let's graph this line. Okay, my y-intercept is at -7, and I'm going to go up 6 and over 1. And I would say let's graph it again, but we already have, okay? So this has, and this is how I like to write it. I like to say the infinity sign. I say infinitely many solutions. All right, let's take a look at this next one. All right, so we need to, actually our first equation again, wow, that's good to go. I can graph 6x plus 4, easy. All right, and this next one, let's simplify this. So I'm going to subtract my 6x on both sides. And so I have negative y equals negative 6x plus 3. Okay, now we don't want that to be negative y. We want it to be a positive y. So remember, it's like there's a little invisible 1 in front of the y. So we're going to divide everything by -1. And then I'm just left with y equals 6x minus 3. And this is something that I can graph. All right, so let's go ahead and graph the first one. My y-intercept is at 4, and I go up 6 over 1. Okay, and I might run out of room, so I'm going to go the opposite way. All right. Remember, you only really need two dots to make a line. Okay, so that's our first one. Our next one, our y-intercept is at -3. And I'm going to go up 6 over 1. All right, now here we've got two parallel lines. These guys are never going to intersect. All right, so we have here no common solution. Okay, so here we've just done three examples, one of each type of solution that we could have. Okay, so we've got one solution where they intersect. We've got infinitely many solutions where we just have the same line. And the last one, no solutions where we have two parallel lines.